Hi, I am Varun Joshi and welcome to day 20 of our Certified Kubernetes Administrator 2025 course. In today's lecture, we are diving deep into one of the most powerful features of Kubernetes Autoscaling. We'll break down exactly how Kubernetes adjusts your workloads dynamically using Horizontal Pod Autoscaler, that is HPA, and Vertical Pod Autoscaler, that is VPA. Before I start with this lecture, I want to show you something. I'll go to my browser. I'll go to the official documentation of the CKA exam. I'll open the official CKA curriculum. I see that the exam was updated on February 18th, 2025, which was a month before. If I scroll down, there is a section workloads and scheduling. It says configure workload autoscaling. It does not mention HPA and VPA specifically. Hence, we should be knowing both HPA and VPA. Another point is the exam now uses Kubernetes version 1.32, but the version that we are using, if I run kubectl get nodes, we see that we are using version 1.31. If I run kubectl version kubectl v, I believe kubectl version grep I version, or just kubectl version, pardon me, then you can see that my client version of the kubectl client is 1.31.1 and my server version is 1.31.4. so I'll leave a link in the GitHub notes for this lecture on how to upgrade your cluster to 1.32. We'll just have to update the kind cluster YAML and we are good to go. So I'll clear my screen here. I'll go back to my diagrams and let's see what we are here to discuss. Scaling. So we know that scaling refers to adjusting the resources available to an application based on its demand and load. So we would want, as the load on our application increases, the resources also continue to increase, and as and when load decreases, we would also want the resources to decrease. Scaling can be thought of two types. There is horizontal scaling and there is vertical scaling. If you see in this diagram, in horizontal scaling, I have an arrow which is lying down. In horizontal scaling, you increase the number of servers or pods. Now, scaling as a concept is applicable to both VMs and pods. Hence, whenever I'm discussing this diagram, that implies to both pods and virtual machines. So when I say horizontal scaling, as and when the load increases, you see there are more number of servers. Previously, there was one pod, and as the load increased, more servers were spun or more pods were spun. Here we have two pods and then here we have two VMs. And this is just an example. This could keep on increasing up to the maximum limit that you have defined based on your application demands. And then there is vertical scaling. In vertical scaling, you see an upright arrow. Upright arrow implies vertical scaling, and then in vertical scaling, you do not increase the number of servers or pods. What you do is you increase the resources in the same server or pod. And I want you to understand, when we are increasing the resources in the same server or pod, that requires a restart. So if we discuss vertical scaling, a pod where you apply vertical scaling will warrant a pod restart. Similarly, if you have worked with AWS and you want to change the instance type of a virtual machine or of an EC2 instance, then you will first have to power that EC2 instance off. You then change the instance type and power that instance on again. That involves a restart. horizontal scaling, the concept can be thought of as scaling out and scaling in. Scaling out means adding more instances or pods. Scaling in means removing instances or pods when load decreases. If the application load increases, you will be scaling out, and as and when the load decreases, you will be scaling in. In vertical scaling, you have the concept of scaling up as opposed to scaling out, and scaling down as opposed to scaling in. When I talk about vertical scaling, we thought of vertical as an upright arrow. Similarly, if you have a ladder, you climb up the ladder and then you climb down the ladder, up and down. Hence, in vertical scaling, we use the terms scaling up and scaling down. Scaling up implies increasing the amount of memory, CPU, or any other resources in a server or a pod, and scaling down means decreasing the resources of a server. This often requires a restart. When I talk about pods, you can achieve horizontal scaling using Horizontal Pod Autoscaler, and you can achieve vertical scaling using Vertical Pod Autoscaler. Similarly, if I talk about normal virtual machines in AWS, you have autoscaling groups which you can use to perform horizontal scaling, and then you have virtual machine scaling sets in Azure to have horizontal scaling for Azure VMs. For vertical scaling, there are no specific tools provided by the cloud providers. What you can do is you can manually power off the server and then increase the required resources, and then you have a server with increased amount of resources. I want you to know one thing: modern applications or cloud native applications would always prefer horizontal scaling, which implies they will be happy to scale out, happy to have more servers as and when load increases, as opposed to vertical scaling, because again, vertical scaling warrants a restart. We'll discuss about nitties and gritties of both these scaling techniques throughout this lecture. Then we discussed that scaling are of two types: horizontal and vertical. Horizontal scaling has two approaches. There is manual approach and then there is automatic approach. Manual approach is you modify the YAML for your deployments. For example, you increase the number of replicas there and then you apply that file. Or you use kubectl scale deployment. The name of the deployment here is my deploy, and then you are saying my replicas, change the replicas to 2. So manual scheduling can be achieved using this. However, when I talk about applications, there are different loads on the application. Daytime there is a different load, nighttime there is a different load, on weekends there is a different load. So you cannot really rely on manual scheduling when it comes to production grade applications or even while doing development. So hence, automatic scheduling is something that you would always see in production environments, and that is achieved using Horizontal Pod Autoscaler. Then there is vertical scaling. Again, vertical scaling can also have two approaches: manual and automatic. The manual approach is you change the requests and limits of a pod and then recreate it. Obviously, when it comes to vertical scaling, the pod will require a restart. And same, automatic vertical scaling can be achieved using Vertical Pod Autoscaler, and a pod requires a restart to achieve the same. So we have discussed about pods in this scenario, but how about the underlying nodes? If I go to my CLI and I run kubectl get nodes, I see there are 2 worker nodes here to run my workloads. But as and when the application load increases, the pods will also require the underlying nodes to autoscale. So how do I achieve that? How do I ensure that my nodes are also horizontally and vertically scaled? When it comes to horizontal scaling of your nodes, then you have a few options. The most common option is cluster autoscaler, and then you can also use Carpenter. You can use any of these tools to achieve horizontal scaling of your nodes. I'll mention here for worker nodes. And then how about vertical scaling of your nodes? Firstly, you will not perform vertical scaling of your nodes, because to perform vertical scaling, you will have to first power off the node and then increase the resources on that node. And that's futile, because all the workloads, all the pods will have to be evacuated, and you do not want that. Hence, vertical scaling when it comes to nodes is not something that you would see in production grade deployments. And then I also want to tell you one more thing. If you look at cloud deployments, like we mentioned before, not all servers have equal resources. For example, some could be your high memory nodes, then you can have GPU nodes which have GPUs, then you can have SSD nodes which have, let's say, inbuilt SSD to provide you with high IOPS, inbuilt storage, and then you can also have high computing nodes which have high number of CPUs. Now, what you can do in production grade deployments is you can have a node group. Now, what is a node group? A node group is a collection of nodes. So what you will do is you will have one node group for, I'm calling node group NG, one node group for this, another node group for this, and so on. And then these node groups will have servers that are of same configuration. And then you can apply cluster autoscaler or carpenter into individual node groups. So that is one approach that you can take, and you will often see that this is the approach that is used. And of course, then the auto scaling of the nodes is provided by cluster autoscaler or carpenter. So you would see these two approaches combined and being used. Vertical autoscaling per se is not used for nodes. Now let's see what is next. Let's discuss Horizontal Pod Autoscaler. It automatically scales the number of pods based on observed metrics like CPU memory utilization or custom metrics. We'll see what custom metrics are in a while, but for now, the most basic deployment of HPA will monitor CPU and memory and will increase or decrease the number of pods based on CPU and memory. Second is metrics server is a prerequisite to use Horizontal Pod Autoscaler. If you remember, in day 19, we discussed how the metrics server have the metrics data. We said that there is a C advisor, container advisor component in the kubelet binary itself. Container advisor exposes an API, and that API collects the memory and CPU data from both nodes and the pods running in your worker nodes. So for example, kubelet is deployed onto each worker node. Hence, each worker will also have a C advisor and a kubelet component, and the C advisor will be collecting the metrics, and then kubelet will be sharing those metrics with the metrics server. And then whenever you use kubectl top for nodes or pods, then the API server will query the metrics server and show that data to you. And also, when we are discussing HPA, HPA also uses the metrics server to query the metrics for memory and CPU. So I would urge you to go and watch the video for day 19, because not only it covers how do you configure metric server, but it also covers requests and limits, which are extensively used along with HPA and VPA. So you must have the understanding of requests and limits before we dive into today's topic, which is HPA and VPA. Then let's get back here. Checks utilization at a 15-minute interval. So this is called a control loop. It is not 15-minute interval, it's 15 seconds, pardon me. So it checks for the utilization at a 15-second interval. Hold on, do I have this wrong in my GitHub notes as well? That's highly unlikely. Just a moment. Yeah, it's correct here. It's 15 seconds. Oh, please pardon me, I had a typo there. Anyway, so it checks utilization at a 15-second interval. There is a control loop that runs, and the HPA controller, if you remember, we discussed in our architecture lesson on day 7 that whenever there is a Kubernetes object, most of these objects have a corresponding controller. So similarly, HPA is a Kubernetes object which also has an HPA controller. So HPA controller checks with the metric server every 15 seconds about the utilization of the pods. HPA can be used with deployments and stateful sets. It can also be used with replication controller and replica sets, but I have not mentioned those things here because you would use the latest and greatest, which is deployment. Now here we said that you can use CPU and memory utilization or custom metrics. The question arises, why do you want to use custom metrics to begin with? If I talk about an application, its performance is not only dependent on how the memory and CPU is being consumed. Of course, memory and CPU are critical metrics, but not load for all applications can be decided by the CPU and memory utilization. You can have several other metrics as well. For example, if my application is network sensitive, I might want to monitor network latency. If my application is storage sensitive, I might want to monitor the IOPS, and maybe my application uses certain external services. For example, if my Kubernetes cluster is on EKS, I might be using Amazon SQS for queues. I might be using SNS for pub and sub. So my application is deployed onto the Kubernetes cluster, and the metrics on the basis of which I want to scale my pods is outside. Maybe the SQS queue length. Maybe I want to increase the number of servers based on SNS service. So how do I do these things? I want custom metrics for that. Hence you use custom metrics when you want to monitor metrics outside of CPU and memory. Now let's see a diagram which explains the metrics in detail. So we discussed that. Here is the kubelet. I'm discussing about the CPU and memory metrics right now. So you have a kubelet here. Nodes and pods are delivering the metrics to the cAdvisor component, that is the container advisor, and then kubelet is sharing those metrics with the metrics server. Now metrics server exposes an API which is called metrics.k8s.io, and HPA controller can query the metrics server using this API and seek CPU and memory metrics, and then based on that data, HPA controller can scale in or scale out. Let's talk about the custom metrics now. As we discussed, there are internal metrics and then there are external metrics. Internal metrics are that are available within the Kubernetes cluster itself. For example, deployments, pods or nodes can provide those metrics. And then there are external metrics, which are essentially services or components that are outside of Kubernetes or are not Kubernetes objects. For example, Amazon SQS, Amazon SNS or Azure functions. So what happens is, for this to work, you first will have to have a monitoring tool. Now that monitoring tool could be Prometheus, Zabbix, New Relic, and there are many other options. So for this example, I have taken Prometheus. What is happening is I have deployed a Prometheus server in my Kubernetes cluster, and this Prometheus could also very well be a Kubernetes deployment, and Prometheus server could be running onto multiple pods for high availability. And then you see a Prometheus adapter. We'll see what the use of Prometheus adapter is in a little while. So what happens is Prometheus server collects all the metrics from both internal and external sources. And then there is a Prometheus adapter. That adapter will convert the metrics received from the Prometheus server into the format that Kubernetes understands. Once Prometheus adapter has that data, it will expose that data using the custom metric API and the external metric API. So the custom metric API is used for internal resources and the external metric API is used for external resources. And then HPA controller can query the custom metrics to have metrics data about internal Kubernetes objects, and then it can also query external metric API to have the data or have the metrics for external systems. And based on that, HPA can scale in or scale out. See, no one is asking you about custom metrics in exam, but I wanted you to know that CPU and memory are not the only options using which you can scale your pods. You have custom metrics as well, and in production environments you would see that you are using application specific metrics for scaling, like the number of HTTP requests pending. There could be plethora of things like we discussed before. So just keep this in mind. Let's move to the terminal and do a demo. I'll clear my screen here and I'll go to this tab. I'll hit cd dot dot. Okay, cd dot dot one more time. I want to be in day 20. I've cleared my screen here. Also I will go to cd courses CKA day 20. I'll press enter. I'll zoom in, clear my screen here as well, and go back to this tab now. The first command that I want to run is kubectl get pods -n kube system. I'm showing you the pods that are running in the kube system namespace, and you see that there is a metrics server already running. So if I run kubectl top pods, then I'll see that since there are no resources, we are not getting any data, but kubectl top nodes should work just fine. So it is showing me the utilization of the nodes, and it is able to show this because I already have metric server installed. Let me now quickly clear my screen. Right, I'll go to my Visual Studio Code. I'll open Nginx HPA, and this is the YAML that we are going to use. We are creating a deployment which is called Nginx deploy. It only has one replica. The label for the pods that are created by this deployment will be app is equal to Nginx, and this deployment will manage any pods that have app is equal to Nginx as label. Then I'm creating a container, Nginx container. I have defined requests and limits 100M and 200M. Then I have a service also being created. This is the cluster IP service, and as expected the selector is app is equal to Nginx, so that this service can load balance across pod or pods that have app is equal to Nginx label. I'll go to the CLI. I'll run kubectl apply -f, and name of that file is nginx-hpa.yaml. I'll press enter, and it says that the deployment and service is created. So what I'll do is I'll write kubectl autoscale deployment. If I press a tab after autoscale, it will tell me that you have these four options. Like I mentioned before, deployment and stateful sets are the ones that you will be using most of the times, and you typically only deployments. Autoscale deployments, then I'll name this deployment Nginx, then I'll say -h for help. If I scroll above, it says that if I want to autoscale a deployment named foo, I can provide minimum is equal to 2 and maximum is equal to 100. This is just an example, and then it will autoscale that deployment, but it is not mentioning what the CPU utilization is, the target CPU utilization, and it says the default autoscaling will be used. So if I just write this command, then this will apply a CPU utilization limit of 80%, as in when the CPU utilization is 80% and more than that, then increase the number of pods up to a maximum of 10 pods. And even when there is no load, I should have a minimum of 2 pods running. That is what this command means. So I'll hit the up arrow. It says kubectl autoscale deployment nginx deploy. I will say that the minimum number of pods should be 1, maximum number of pods should be 5, let's say, and then the CPU percent should be 50%. No, percent is already there, so I don't need a percentage sign here. I'll press enter now. It says that horizontal pod autoscaler whatever nginx deploy autoscaled. I'll run kubectl get HPA, and then the name is nginx-deploy. I'll press enter. It is saying that the HPA nginx deploy, the name of that HPA is nginx-deploy. The reference is the thing that this HPA object is working on is a deployment with the name nginx-deploy. These are the targets. Current target is 0, as in the current utilization of all the pods combined is 0%. The target is 50%. It says that when it hits 50%, then start scaling out. So it will create a maximum of 5 pods, and even when there is no load, the minimum number of pods should be 1. The age is 16 seconds and the current number of replicas running is 1. It is 1 because if I go to my YAML file, we have deployed replicas as 1. So I'll go here. What I'll now do is I want to generate some load so that we can see HPA in action. But before I do that, I want to run a describe on the HPA so that you can see some more information. If I hit describe, then you would see that it says that the desired count is within the acceptable range, and whatever we saw before, we are seeing a detailed version of the same thing. There is some additional information as well. So now let's do one thing. Let's increase the load on this pod and see HPA in action. So what I'll do is I already have a command ready that will increase the load. What I'll do is I'll open another tab, I'll zoom in, and then I will paste that command. So I want to explain what I'm doing here. I'm saying kubectl run, that implies run a pod, -it implies give me an integrated terminal. I'm saying -rm, which says once I exit, delete this pod. I'm naming this pod load generator 1. Image that I want this pod to use is busybox. This is the command that I'm running. I'm saying open a shell -c. This is the command sequence. I'm saying while true, and this will always be true. This is an infinite loop. Do wget -q quiet, and you go to this service and done. This service is the name of the service we just created. So when we applied this YAML, you see that this created two objects, a deployment object and a service object, and we separated both these YAMLs using a YAML separator, which is triple hyphens. And here you see that we are naming this service nginx-svc, which is why here we are saying go to nginx-svc so that this service can load balance between the pods that have the label app is equal to nginx. I hope this is understood. And right now there is only one pod. So if I press enter, this will start generating the load, and then I'll open one more tab, and here also I will run the same command. I'll have to name this load generator 2 because load generator 1 is already running. I'll now go to my tab. I'll now run kubectl get HPA nginx deploy. So if you see, it says the utilization has increased to 119%. If I run kubectl get pods, oh, it's so quick. In 16 seconds back, it spun up 2 pods. The HPA is in action. So if I run kubectl describe HPA nginx deploy and press enter, you see that 32 seconds ago there was a successful rescale. New size is 3. Reason CPU resource utilization, percentage of request above target, and that is what we discussed. So as soon as it saw that the load is increasing, it spun up more pods, and right now you see it has spun 2 more pods, and the maximum that we specified were 5 pods. If I run kubectl get HPA, I should see what is the current utilization. It's still 62%. If I would have specified the maximum for auto scaling more than 5, then it would have spun a 6th pod as well. So this we understand, and we have seen this in action. Let's see if I wanted to talk about something else in HPA. Let's run kubectl events. I want to show you this output as well. If I go to kubectl events, you would see that you can see this event here as well. We saw this in kubectl describe HPA too, but you can see this in kubectl events as well. Now I'll clear my screen. I'll write kubectl delete HPA. That's how you delete an HPA object. Nginx deploy. Then I will run kubectl delete -f nginx HPA. I'll press enter. So both of these are deleted. I'll clear my screen. I'll run kubectl get pods. I should see no resources. I should see 2 resources, and they will be deleted as soon as I exit that container. So I'll press Ctrl C. It says load generator 2 is deleted, and then I press Ctrl C here and it says load generator 1 is also deleted. These are deleted as soon as I exited because I used -rm flag. If I now run kubectl get pods, I see no resources found in the default namespace. Now let's move to VPA. I'll go to my diagrams. I will scroll down. The definition of VPA says it is used to automatically adjust the CPU and memory requests and limits of your pod based on their actual usage. Let's move to the top, and we discussed here that vertical scaling often requires a restart. So when we talk about Vertical Pod Autoscaler, it will also restart my pods when applying the recommendations. So let's go to my GitHub notes. I will scroll down a little, and here I see VPA, and I want to, so we want to install VPA first. There is VPA installation guide. You can refer this guide, or you can follow the steps that I have mentioned here. So first you will clone this repository. I have already cloned it. If I go to my CLI, if I run ls here, you see that autoscaler is already there. So I have already cloned this. Then I will go to this section. I'll go to this directory, and then this is the command to install all the components, or rather all the objects that are required for VPA to function properly. I'll press enter, and you see it has created so many objects for us. The objects that I want you to concentrate here are 3 deployments, this one, and there will be 2 more. So VPA updater, VPA recommender, and VPA admission controller. So you should know what these are at a very high level. So if I go here, you can see the definitions for them. A recommender continuously analyzes historical and current usage, and it will recommend the optimal CPU and memory. Then there is updater. Updater identifies pods needing resource adjustments, evicts and restart them to apply new CPU memory settings. I want you to concentrate on this thing. It respects pod disruption budgets to maintain application availability. There is pod disruption budgets. These are configured to ensure that even when there are scaling in or any operations that removes the pods that are happening for this particular deployment or this particular application, do not go below these number of pods. So updater respects pod disruption budgets. Then there is admission controller. It intercepts pod creation requests, modifies CPU and memory requests at creation time based on the latest VPA recommendations. So these things will be installed, and once this is done, we are good to go. So if I go back to the CLI, I'll quickly clear my screen. I will run kubectl get pods -n cube system. If you see here, these are the 3 pods that are created by the installation that we just performed. So once you install this, then if you see here, I have another YAML called VPA.YAML. This exists in day 20 itself. This is for Vertical Pod Autoscaler, and we know that we can check these things using kubectl API resources grep -I'll grep for vertical, and once I press enter, I see that Vertical Pod Autoscaler VPA is the short name. This is the API for it, and then it is namespaced true, and the kind is Vertical Pod Autoscaler. So we are calling this Nginx VPA. The spec, the target reference, so the deployment that this VPA will be targeting is apps1. The version for API version for deployments is app1, apps/v1, kind is deployment, and name is nginx deploy. So we'll be creating nginx deploy from this nginx VPA.YAML, and then update policy. So this is an important part. If you install VPA, you will see that it has 3 modes. There is auto mode, there is off, and there is initial mode. Off is VPA will only recommend what should be the requests, and then it will not perform any restarts of the pods and won't apply any requests to any of your pods. Then there is initial. Initial is VPA sets recommended resources at pod creation. So once the pod is created, it will set the request and then it will not change afterwards. Then there is auto. A VPA automatically updates resource and restarts pods as needed. So this is a continuous process. As the resource requirements increases, it will scale up the pods accordingly and it will scale down as the demand decreases. So these are the three options that you can have. For this demo, I have selected auto right now. First, I'll create this deployment nginx-vpa. So we are doing the same thing here. The replicas that we are creating are 2. Then we are using requests and limits. We are setting 100 M for the CPU. Then if I scroll down, I am creating a service as well, like we did before, and this service will be distributing the traffic between these two replicas. Now we must understand that VPA is scaling up, not scaling out. So you won't see the number of replicas increase like we saw in HPA. Here you will see the configuration of the servers, the requests essentially decrease on increase based on the recommendations given by VPA. So I'll go here, I will go 2 steps back and then I will run kubectl apply -f nginx vpa.yaml. So it says it is created. I'll clear my screen. I will run kubectl get pods. I see there are 2 pods running. Now I will run kubectl describe pods and I'll describe one of these pods and S2. And I see whatever I have given in limits and requests, 100 M, I see that here. If I go to the YAML, I see 100 M, that is what I specified. So this is what I expected. What I'll now do is I'll apply the VPA object. I'll run kubectl apply -f vpa.yaml, and vpa.yaml was this one, and this now stands applied. So it will automatically modify my pods based on the recommendations given by VPA. So I'll run a kubectl get VPA nginx VPA, and it shows me that there is a VPA object with the name nginx-vpa whose mode is auto. CPU and memory statistics are not received by the VPA object yet because we have just deployed it, and the age is 18 seconds. If I run this command again, I should see some memory statistics. So let's give it some time. Until that time, let me run a kubectl describe VPA nginx-vpa. I'll press enter and it has started giving some recommendations as well. So if it's so quick, you see that evicted pod 2 seconds back from VPA updater. VPA updater evicted pod nginx deployed this to apply resource recommendations. It was so quick, and the recommendation that VPA has provided is there are few lines here, lower bound. So this states the minimum recommendation I suggest you for CPU and memory requests is 25 M, and this is 262 megabytes. The target, this is what you should be configuring, and this is what this VP object will configure, is 25 M of CPU and then memory of 260 megabytes. And then you have upper bound. Upper bound is, this is the maximum that VPA thinks your application could use, but these are very high numbers. You might not need these numbers, so take this with a pinch of salt. Then let's do one thing now. I will run kubectl get VPA nginx VPA. This says that I have provided my recommendations, and let's run a kubectl get pods. I see there are 2 pods that are running, and these are those 2 pods. If I run kubectl describe VPA, then I will see that it evicted both my pods and recreated both those pods with the updated recommendations. Now let me run kubectl describe pods, and then I run nginx, and then let's see this pod, and let me scroll up. I applied the limits initially in my pod. You see this? I applied both requests and limits, and the number for those were 100M. Okay. If I go back here, the VPA has changed the request for CPU from 100M to 25M. The memory I did not specify, but it has added the requests for memory as well. When I use VPA in production, what I do is I always keep this to off. This is auto. I keep this to off. In off mode, VPA only recommends resources, does not apply them. Then Varun, what is the use of having VPA if you don't let it automatically do its job? The point is, at times you will have application teams come to you and they tell you that we do not know what should be the requests and limits for our application. We have not tested that. In that scenario, VPA object is extremely useful. What you can do is you can deploy their application and then see via the VPA object how much should be the requests for those applications. And then once you have the recommendations from VPA, you can configure the requests and maybe take 20-30% buffer and configure the limits as well. So this is the use case for which I have used VPA both in development and production environments. And Horizontal Pod Autoscaler HPA I have always used, and there is no production deployment that I have seen is not using HPA. Let me see if there is something else I want to cover. We have seen both HPA and VPA in action. That wraps up our deep dive into Kubernetes Autoscaling with HPA and VPA. You should now have a strong understanding of how Kubernetes handles scaling both horizontally and vertically. In the next lecture, we will discuss multi-container pods and the patterns behind them. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing and subscribing. It will mean a lot to me. Thank you very much.